Hi everyone. In this lesson we want to look at how we solve radical equations, and in particular we're going to start with some real simple square roots. Now the general idea can be illustrated by looking back at a simple linear equation. And we know that to solve an equation like this, 2x plus 1 equals 7, we can think of it like a present, like a Christmas present or a birthday present that you unwrap. And I'm trying to find out what's inside that present. I'd like to find out what x is, and the way I unwrap that present is by applying opposites or inverses that we call them in math. Okay, so in this case I start off with 2x plus 1 equals 7, and I unwrap the plus 1 by subtracting 1 from both sides, right? And if I subtract 1 I'll get 2x equals 6. And then I unwrap the 2, right? I undo the multiply by 2 by dividing by 2. And when I divide by 2, then I find out what's inside. I know that x has to equal 3, and that's my answer. Well, we do the same thing, something similar, when I have square roots. I want to unwrap this present, and so I'm going to go ahead and subtract 1 from both sides, just like we did up here. I subtracted 1. So that would give me the square root of x minus 2 equals 6. And then how do I unwrap a square root? Well, I do the opposite. I would square both sides. So if I square both sides, then on the left-hand side I would square the square root. That would give me x minus 2. And if I square the right side, that would give me 36. And so I'd get my answer, x equals 38. Okay, and notice if I plug 38 in up here, 38 minus 2 is 36, and the square root of 36 is 6, and 6 plus 1 is 7, and it really does work. Okay, so in general, that's what we're going to do. We're going to try and get the radical all by itself on one side, and then I'll unwrap that radical by squaring both sides. So let's do that on this example. So if I had the square root of 2x minus 3 plus 3 equals 0, the first thing I want to do is take that 3 on the other side. I'd want to subtract 3. All right, and then I'll square both sides to get rid of the square root. Then that would give me 2x minus 3 equals 9. And so 2x is equal to 12, and x would be equal to 6, right? And so my answer is 6. Well, we'd think it might be 6 until I go up and check it. Now notice when I go and check this, if I plug in 6, I'm going to get 2 times 6 is 12, and 12 minus 3 is 9, and the square root of 9 is 3. 3 plus 3 doesn't equal 0. Okay, so it doesn't check. So we can see here, if I plug in the 6 that I think the answer is, right? 2 times 6 minus 3 plus 3, that's not going to equal 0, right? I get the square root of 9 plus 3, and 3 plus 3 does not equal 0. Okay? Well, what went wrong? Well, what went wrong? We did everything correct, but actually right here, when I took the 3 over, if I'd had my wits about me on this one, I would realize that a square root can never equal a negative, right? The square root is the range of the square root function is always something greater than or equal to 0. So right here something is wrong, but when I squared both sides, I was misled to think that the answer might be 6. Now this leads us to one of the places in algebra where we can do everything right and still get a wrong answer. And so we have a great big danger right here. We want to really maybe put some stars by this. Okay, if you ever square both sides of an equation, this is the one place where you absolutely must check your answer. And the previous example illustrates why, but I also want to share just a little bit more about why. Here's the easiest way to see it. Here's a real simple equation, x equals 2. The answer is 2. If I plug in 2, it makes it true. All right. Now, if I were to square both sides, then I would get x squared equals 4. Well, notice here that 2 is still the answer, but by squaring both sides, I introduced another answer as well. Notice that negative 2 makes this equation true, but negative 2 doesn't make the original equation true. Okay, so negative 2 is also a solution, but not a solution of the original one. Okay, so that's what can happen. If you ever square both sides, you may introduce an extraneous solution that's a solution of the result you get when you square both sides, but it's not a solution of your original equation. So that's why if you ever square, you have to check your answer. You may have introduced, just like we did in this previous example here, you may introduce an extraneous solution, right? X equals 6 is a solution of this equation, but x equals 6 is not a solution of my original equation. All right, let's do one more example here. Suppose I'm asked to solve 2 square roots of x equals x. Okay, I've got to square it on this side. I've got an x on this side, but if I just go ahead and square both sides, I will get rid of that square root. So I'll have to square the 2 as well. That gives me 4x on the left side equals x squared. And then this is a quadratic equation, so I'm going to go ahead and take everything over on the right-hand side. So I get 0 is equal to x squared minus 4x. And then I can factor this. This factors very easily. Just factor an x out. And you can see that x equals 0 or x equals 4 are potential solutions. Okay, so let's go up here and check and see if they are in fact solutions. All right, so if I check x equals 0, you can see that 2 times the square root of 0 does equal 0, so that one checks. And if I plug in 4, x equals 4, 2 times the square root of 4, that does equal 4 as well, right? Square root of 4 is 2, 2 times 2 is 4. So in this case, they both check. They're both solutions. Okay, so it may turn out that you may end up with if you have 2 solutions like we did here, maybe both of them are solutions. It may work out that only one of them is a solution, and it's possible that neither of them will be a solution. You just absolutely have to check. Okay, last problem. Notice this problem is written as a rational exponent, as a fractional exponent instead of the square root, but we understand that this is a square root, isn't it? That's the square root of x minus 3. So I could do the exact same procedure. Go ahead and subtract 7 from both sides. So I get x minus 3 to the 1/2 equals 4. And I could even just write a square root instead of a 1/2, but I'm going to leave it as a half just to illustrate that when I square both sides to get rid of the square root, my rules of exponents also work, right? Because when I square the 1/2 power, I multiply those exponents, and then that gives me just x minus 3 to the 1 power equals 16, and my x is equal to 19. And if I take 19 minus 3 over here, that's 16. The square root of 16 is 4, and 4 plus 7 is indeed 11. So that's my answer.